Hey guys, today we're going to launch into Chapter 1 and we're going to be talking about Lesson 1.1. Yeah, we're going back to Chapter 1 and we're going to talk about finding GCF and LCM. Okay, so we're going to talk about different strategies that I use when I'm asked to find a GCF or an LCM. So let's go ahead and make sure that everybody understands what I mean by those abbreviations. So we're going to talk about a GCF, which is known as the greatest common factor. Okay, we've been using GCF when we've been simplifying fractions. Now let's kind of make sure everybody understands each of these words. Greatest means largest. Common means same. So something that two numbers or more have, that's the same. And then the hard one to define, because it's long, is a factor. And a factor is numbers that are multiplied to give a product. Okay, so I'm going to look at two numbers and I'm going to show you a couple different strategies I like using, and I'm going to focus in on two. Okay, so strategy one is called prime factorization. Now, in a prior set of notes, we talked about that a prime number is a number that has only two factors that can give you that number. So, for example, 3 is a prime number. The only two numbers I can multiply that give me 3 are 1 times 3. 19 is prime. 1 times 19 is the only way that I can multiply two numbers and get 19. And then we have other numbers that are composite, like 12. I could get 12 by multiplying 1 and 12, but also 2 times 6, but also 3 times 4. Okay, so this is how prime factorization works. We're going to take our two numbers, find a different color. Keep repeating my colors here. Let's do orange. 24 and 36. So what I'm going to do is deal with one number at a time, and I'm going to branch numbers out from it. So I can come up with any two numbers that would multiply to give me 24. So I just thought of 12 and 2. Now 2 is unique because it has only two factors, 1 times 2. So it's the only even number that's prime. But 12, we just mentioned, had lots of factors. So let's do 3 and 4. Ooh, 3 is prime, 4 is not. And what I do is every time I hit a prime number, I circle it up. Once all I have at the ends of my branches are circled numbers, then I can say, oh, I know what this value is. I have its prime numbers. So what I'm going to do is take 24, and it's the same as 2 times 2 times 2 times 3. And I put the numbers in order from least to greatest. Okay, let's do the same thing to the number 36. So let's see, we get 6 times 6. They have factors that's even, so I know 2 goes in 3 times. Ooh, 2's prime, 3's prime. And then I have 2 times 3. So then when I write 36, I have 2 times 2 times 3 times 3. So what do I do for GCF? I look at what do they have that's the same. What do they have that's common? They have a 1, 2. they have another 2, and they have 1, 3. The other two numbers don't match each other, so then I just multiply that out, and 2 times 2 is 4, 4 times 3 is 12. Now some people may already understand looking that that's going to be the answer, but that's okay if you don't. Now actually, the guy I think I like better is called the factor ladder. Now, I've heard this called upside down wedding cake. I've heard this called layer cake. I'm just going to call it a factor ladder. So what we do for a factor ladder is we take 24 and 36, and then we're going to put kind of like a capital L that's fallen down. And what we're going to do is think about what's a number that goes into both of them. And it really doesn't matter how you put the numbers in, okay? Really doesn't matter. So let's think about this. What can go? They're both even, so let's pull out a 2. So 2 goes into 24 12 times. 2 goes into 36 18 times. But I notice the numbers are even, so that means I could pull out another 2. 2 goes into 12 6 times, and 2 goes into 18 9 times. But you know what? I know that there's a number 3 that can go into both of those. So I'm going to factor out a 3. 6 divided by 3 is 2. 9 divided by 3 is 3. And then I have a problem where I've got 2 numbers at the bottom and there's nothing more I can pull out. So, how do I figure out GCF? Oh, this is great. All I do is I look at the vertical numbers and I multiply them together. And that gives me 12. Isn't that cool? Okay. All right. That's GCF. That's a way for us to figure out, excuse me, the greatest common factor that 2 or more numbers have in common. Okay? If it's more than 2, it has to be something that all the numbers have to have in common. Let's talk about LCM. So LCM, and we were practicing this as LCD, least common denominator. So we've got least common multiple, and over in parentheses I'm going to say or denominator. And again, we're going to, what do each of these words mean? Well, least means the smallest. So sometimes when I say, okay, I have a denominator of 3 and a denominator of 6, and I'd say, okay, what would be the common denominator? A lot of you guys would tell me 3, but it has to be a number that both 3 and 6 can go into evenly, and 6 can't go into 3. Common is the same thing as we had before. It means same. So it has to be something that's the same between 2 numbers. And then multiple, it's numbers can both divide into this value. Another way of thinking about multiples is when you did the multiples of like 3, it'd be 3, 6, 9, 12, 15, 18, so on. How did you get those? 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, and so on. Okay, so I'm again going to do prime factorization. And I am again going to use exactly the same 2 numbers so you can see how they both work. So I'm just going to do, let's say 3 and 8. 3 is a prime number, 2 and 4. 2 is a prime number, 2 and 2. And so then I would say 24, and I'm just going to put them in order. 2 times 2 times 2 times 3. And then let's do 36. Let's see, that's 4 times 9. 4 is 2 times 2, they're both prime. 9 is 3 times 3, they're both prime. So notice I did my, oops, threw my pen. I did my numbers this time a different way, and I still came out with the same prime factorization. That's the beauty. So this is where it gets a little tricky. Instead of writing it the way I did, what I'm going to do is be a little bit more careful, and I'm only going to line like numbers underneath each other. So notice that I had partners for 2 of the 2's, but the third 2 didn't have a partner. I had a partner for 1 of the 3's, but the other 3 didn't have a partner. So what LCM says is that I'm going to take a number from each column. Okay? And I multiply them together. So what's the smallest number that 24 and 36 can go into? It's going to be a lot bigger than 24 and a lot bigger than 36. So I'm just going to do my math. I get 2 times 2 is 4. 4 times 2 is 8. 8 times 3 is 24. 24 times 3 is 72. 24 goes into 72 3 times, and 36 goes into 72 twice. Okay, so I'm still doing prime factorization, but I'm using it a different way than when I was doing LCM. LCM, I only circled up what they had, what was the same. In GCF and LCM, I take the numbers that paired up, but I also had to include the numbers that did not have a pair. Oops, I went backwards. All right, so let's see how I do the factor ladder. This is why I like this one, because I think it's so much easier to do the factor ladder to come up with the least common multiple or least common denominator. So we're going to start off the same. We're going to have 24 and 36. We're going to create that first rung of our ladder. And I'm going to start any way I want. Any way I want. It does not matter. I like to just start off with the smallest factors that are possible. So I'm going to try a 2. 2 goes into 24 12 times. 2 goes into 36 18 times. Those numbers are still even. So I'm bringing in a different rung. 2 goes into 12 6 times, and 2 goes into 18 9 times. I'm going to put in a different rung. 3 can go into both numbers. 3 goes into 6 twice, and 3 goes into 9 3 times. So how do I find LCM? How is LCM different in this case? I'm going to take all the numbers. See, I'm making a big, huge L. And I take my huge L and I multiply all the numbers together. 2 times 2 is 4. 4 times 3 is 12. 12 times 2 is 24. 24 times 3 is 72. So the factor ladder, if I want GCF, I look at the vertical numbers. If I want the LCM, I look at all the outside numbers that form an L. And there you go. Good luck with this, guys. Talk to you soon.